This is most of lesson 11.2, areas of circles and sectors, as well as a little bit of 12.1, probability. So we're going to start off by defining a sector. So a sector is essentially a slice of a circle. So it's the region bounded by two radiuses, right, like this one, and then the intercepted arc. So all the space inside that bounded region would be a sector. We can find the area of a sector in the same way we found an arc length. We're going to set up a proportion, and it's still going to be degrees over 360 equals, and now it's the area of the sector over the area of the whole circle, which would be pi r squared as our only formula, or just a if that's what we're dealing with. So for example 1a, we're going to find the area of the red sector, which would be the one with arc UV. So the degrees of the sector that has arc UV is 70. So 70 over 360 equals area of the sector, which is what we don't know. So x over pi r squared. And in my problem, I know my radius is 8. So cross multiplying is going to give me 360x equals 70 times pi times 8 squared, which is 14074.3. And when we divide by 360, we get 39.1, and this was inches, so inches squared because we're dealing with area. For example 1b, it's now asking for the blue sector, or the one with arc USV. So they didn't tell us how many degrees this arc is, but if the red one was 70, and this is everything else, 360 minus 70 is really 290. So our degrees are 290 over 360 equals x over pi times r squared, so pi times 8 squared. So cross multiplying, we have 360x equals, oops, typed thing in wrong, my calculator. $58,307.96, just to write it out, and I will divide by 360, and I got 161.966. So I'm going to go to the hundredth just to make it easier, 0.97 inches squared. If you wanted to go to the 10th, that would have been 162.0. All right, here's a check-in. You could pause. Answers are posted on Google Classroom. So for example 2, we're going to find the area of the whole circle. So what they're telling me here with this A equals 35 square meters, that's just this sector. So degrees over 360 would be 40 over 360. Area of the sector would be 35. And area of the circle is what we don't know. We just put the letter A there. So when I cross multiply, we're going to have 40 times A equals 35 times 360. And when we divide by 40, I get 315 meters squared. So there's no check-in for this. Instead, we're going to talk about area of a shaded region. So you will either need to add two areas if your shape is made up of non-overlapping shapes, or find the entire area and subtract the unshaded portion. So you're going to have to look at each problem and decide what will be done in that particular figure. So for example 3a, it says a rectangular wall has an entrance cut into it. You want to paint the wall. To the nearest foot, or I should say to the nearest square foot, what is the area of the region you need to paint? So we're dealing with one big rectangle. That's the wall. And if I was painting the whole wall without the opening cut into it, I would just find the area of the shape, which would be 36 long by putting together the 10 and the 16, 26 high. So this rectangle would just be the whole wall, including the cut open part. But I'm not going to paint the cut open part, so I need to take it away. So the cut open part is really made up of two pieces. There's one piece here, which is 16 long by 16 high. So this square is 16 by 16. And the other thing we have is half of a circle or a semicircle. And all the way across the circle was 16, which means halfway across the circle was 8. So for our semicircle with a radius of 8, we would do half of an actual circle. So let's find our pieces. We're going to take the big rectangle and we're going to take away the two parts that were cut out. So the big rectangle is 36 times 26, which is 936. The small square is 16 times 16, which is 256. And the semicircle is going to be half of pi r squared. So half of pi 8 squared. I do need to square the 8 before I cut it in half. So 8 times pi, divide that by 2. This area was 100.5. So my overall painted area will be 936 minus the square minus the semicircle. So we should get 579.5 feet squared. If we look at example 3B, there's no cutout portion. We have one shape here, which is half a circle. We have a different shape here, which is a triangle. And that's all our figure is made up of. Nothing got taken away from either of these shapes. So we can find the area of each independent one and combine them. For my semicircle, the diameter was 7 because all the way across was 7. So the radius is 3.5. So this area would be half, because it's half a circle, of pi times 3.5 squared. So for this one, I get about 19.2. For the triangle, we know area is 1/2 base times height. So even though it's drawn upside down, 7 would be the base, 7 would be the height. So for that, we get about 24.5. So now I'm going to add these two together. So we have 19.2 plus 24.5, and I get a total area of 43.7 meters squared. So here's a check-in for you to try. To me, this looks like a rectangle with 2 halves of a circle or 1 whole circle cut out of it. So try to find the area of the shaded part. Go pause. Answers are posted on Google Classroom. The last thing we'll talk about is probability. Probability is the likelihood that an event will occur. And we find probability by dividing the favorable outcomes, that means the outcomes that we want, by all possible outcomes. Because this is geometry, we're going to look at geometric probability, which is going to be the area of a specific region over the area of the entire region. So for example 4, it says find the probability a dart would hit the circle. So that means our probability is going to be the circle over the whole shape, and the whole shape happens to be a square. So we're going to put the area of the circle over the area of the square. So my circle has a diameter of 18, which means it has a radius of 9. So the circle is going to be pi times 9 squared. The square is length times width, so that's 18 times 18. So this is going to be 81 pi over 324. If this was something like a final exam, They may give the answer as exact, in which case they would do 81 over 324. They would reduce the fraction, and that's 1 over 4. So my answer would have been pi over 4, and that's a perfectly acceptable answer. Another thing we could do is actually divide it and get it as more of a percentage. So 81 times pi, divide that by 324, and multiply it by 100 to get a percent. So if I actually converted this, did the division, times 100, we get 78.5%. So depending on what the question's asking, how they want the answer, you may have to do one or the other. So here's check-in 4. Answers are posted on Google Classroom, but that is the end of section 11.2 with a little bit of 12.1.